So this is Universe Sandbox, and it's slightly different, well, quite different than Space Engine, actually, with a lot of really, really cool features. Wow, time was going pretty quick. Let me slow down. So I've actually been messing with the Universe Sandbox a little bit off camera before I started the video because I wanted to get a little more acquainted with it before I threw us into a bunch of videos and didn't know what the hell I was doing. And there's a lot of really, really cool things that you can do in this game. Like, a lot. I mean, there's empty simulations, preset simulations, guides, workshop material, performance tests, which I should have probably done that already too. But I mean, look, you can do so many neat and interesting things here. Let's see, tools, add. Let's see. So here's our sun. Boop. That's our sun right there. Plain as day. Pun intended. Okay. Let's see here. I can actually, if I go to view, I can turn on the habitable zone. Here we go. This shows you how far away certain planets would have to be in order to orbit, in a habitable area where it's not going to be too cold, it's not going to be too hot. And, I could probably freeball it and just guess about where Earth is, because I actually already know that Earth is at 1 astronomical unit. So Earth is right there. That's where Earth is. Boop. Now to put it in perspective, if the Earth was only 10% closer to the sun than it is right now, or 10% further out from the sun where it's at right now, we would have 3 different worlds to be living on. Let me start the simulation, and we'll let the temperatures adjust accordingly before we go look at them. So this is the Earth that's in its correct location, or it should be, I think. Let's look at it. So this Earth is just short of 1 astronomical unit as far as where its semi-major axis is. The average temperature on this Earth is 5 degrees Celsius. That's actually cold. That's way colder than it's supposed to be. Put it in Fahrenheit, the average temperature is 41 degrees. That's pretty chilly. I bet this one here is actually closer to the average temperature. This one's actually a little warm. This middle Earth here, or the Earth that's closest in, appears to be a little closer to the sun. Average temperature is 20 degrees Celsius. That's a little hotter than normal. That means the ice caps would definitely recede a little further than they would have otherwise. I don't even know if we have a southern ice cap. Do we even have Antarctica anymore on this planet? I don't see it. I think time is paused. Okay, yeah, it's paused. I don't think Antarctica exists anymore. I think we've lost Antarctica. I think it is melted. But I could be wrong. Anyway. But, there's that Earth. And, of course, this Earth here is going to be quite cold. Yeah, -7 degrees. So the average temperature on this Earth is below freezing. Oh, God. As you can tell, life on this planet would only be sustainable around the equator. The temperatures here seem to be far too cold for life to survive on. Way too cold. And I think the habitable zone is what you see glowing there. Yeah. That's interesting. So, yeah, if you wanted to survive on this planet, it looks like South America, perhaps middle of Africa would be your go-to locations. That's pretty cool. I like that. But that just goes to show, we had to be in the exact spot that we are to get lucky enough to have an orbit that was just hot enough and just cold enough for things to be where they are right now, you know. And of course our sun had to be the type of sun that it is, you know. The Earth had to be, you know, rotating and not tidally locked. I mean, for example, I mean, I'm just going to keep probably just doing random things to prove points here, but like, you know, if we add the sun, let's just add our sun right here. Okay. Now, if we add the planets to our sun, here we go. So now all the planets are around the sun. Now, what if our sun was a little more luminous than it already is? What if it was twice as bright as it is already? The total energy released every second. Let's make that 2. Boom. Now, the surface temperature, I believe, rose quite a bit, and I'm willing to bet that this is going to make quite the difference on our planet as well. Let's check. The average temperature is 8 degrees Celsius. That's actually that's rather cold. I wonder if changing the luminosity actually made it cooler. I didn't think that was how it worked, but it could be. It says 8. Average temperature is 8 degrees Celsius. On here, though, it says, if you go back, right here, it says the average temperature is 14 degrees Celsius. So I'm not quite sure what that means. It may be a little off, maybe a little buggy, but let's, just for the hell of it, I want to see if changing the luminosity actually does affect anything. So let's run this simulation for a little while. And as you can tell, we don't all orbit the sun on the same plane. Pluto definitely doesn't orbit. Pluto's going at quite the eccentric orbit. Like, looks like it's what, like 20 degrees, maybe 15 degrees, something like that. Okay. Let's slow it down now and go back to the Earth and see if anything has changed. Average temperature is 59 degrees Celsius. Oof. Holy crap, that's hot. That's 138 degrees. So yeah, changing the luminosity of our sun definitely had an effect on poor planet Earth here. My goodness. I'm surprised that there's any polar ice caps left at all, but I imagine that they will eventually completely disappear. Wow, that's hot. That's really hot. I'm surprised. Well, the boiling point of water is pretty high, so I shouldn't be surprised that there's water on the planet. But look how there's hardly any green. There's no grass left. Everything is burned alive. No trees, no foliage, no nothing. Oof. Although that does lead me to wonder how Mars is now. I wonder if Mars is any warmer than it was before. Mars was originally pretty damn chilly, like negative 80 degrees Celsius. And now Mars has water? Did it get so hot that... What? What's going on with Mars? This may not be accurate scientifically. The average temperature on Mars, yeah, it's still negative 71 degrees Celsius. Mass. It's half the size of Earth radius-wise and only 1/10 the mass of Earth as far as, you know, what makes it up. Yeah, I'm not sure what Mars is doing here. I do want to check out one more thing, though. If we're going to be checking planets that may have changed, or celestial bodies, let's go to Saturn. Although, I don't think Saturn's moons are going to be here, are they? No. Nor are the rings, because I think I have those turned off. But this is just to see what it's going to be like if. Of course, I'm going to have to simulate this for a minute, but with the sun being twice as luminous as it already was, God, that's trippy looking. I'm curious, you know, what'll happen with Titan. If we can find Titan, there it is. I wonder if Titan's any warmer than it was before because of how luminous the sun is. Nope, negative 189 degrees Celsius. So still pretty freaking cold. You hate to see it. And of course, I guess there are parameters here that we could mess around with that would potentially, you know, affect Titan's temperature and all that, like average temperature and all that stuff. We could adjust certain things, like you see, its atmosphere and all that stuff, surface pressure, which I am not quite smart enough to figure out. Like, I don't really know, you know, how to adjust that stuff. But Earth similarity, 16.2%, life likelihood's 0. But when you compare that to Saturn, what that is Saturn, sorry. Here we go. Earth similarity, 23%. Orbital elements. I was looking to adjust the, I was wanting to check out the atmospheric information here, but I guess I've already passed it. Or maybe it was an overview. Surface gravity is not that bad. Pretty similar to Earth's. Yeah. I don't know. Interesting stuff. I'm kind of just fiddling around here. Let's see. Let's start a new simulation. I'll tell you what. Let's start a new simulation. Just a new solar system simulation. Here we go. So we'll do just planets. Now, let's go to the Earth. And let's place Titan around us. Here we go. Now, I'm not sure how many kilometers away Moon is. I don't remember. I guess we could find out the easy way though. Let's just do this. I want to place. Here we go. There's the Moon. Okay, so I want to place Titan just as far away from Earth as our own Moon is. So if we do that, let's see. Looks like our Moon is. Yeah, that's really far away. Not even a tenth of an astronomical unit, which makes sense, I guess. Okay, we'll go about right there. All right, that's cool. Okay, so if we do that, we can delete the Moon now if we want. I'm curious, being this much closer to the sun, and with Titan actually having an atmosphere, if we run this simulation for a hot minute, is Titan going to become any more habitable than it already is? Or is it still just going to be a frostbitten, you know, freezing cold, you know? Is it even in orbit around Earth? Is it? Yeah, it is. It's just not showing the orbits for some reason. I don't know why. That's weird. It should be showing the orbits, but it's not. There we go. I guess I must have clicked it off. All right, so as you can see, the average temperature is rising. And that's what we want to see. Let's see where it caps off at. Still rising. Over here on the right side of your screen, -150. I'll put that in Fahrenheit for the hell of it. It's still exceptionally cold, but I'm willing to bet that'll keep rising and rising. And yeah, it's still going up. Sorry if this is disorienting to watch. It is kind of bleh-inducing. Look at that. We are now 1 degree. I wonder how high it'll get. Oh, I think it's starting to taper off a little bit. Or maybe not. Maybe it's going to keep rising. I think that Titan has a thicker atmosphere than we do here on Earth. So it's subject to have a stronger greenhouse effect, I believe. Which means it will be warmer than us, I think. It looks like 30 degrees Fahrenheit, though, is the average temperature. That's not bad. And actually, I'm wrong. I was reading it as I was thinking in Celsius. So it's still going to be cooler than Earth. because Earth's average temperature is 15 degrees Celsius, and looks like this is going to be sitting right at 0 degrees Celsius. So that is still 30 degrees. We can work with that. We could 100% work with, if our moon had this atmosphere and this temperature, we would already have had it terraformed, I guarantee it. Or we would have been trying to terraform it anyways. That's pretty crazy. So that's pretty nuts. Let's look at let's see if we go to surface gravity. Yeah, 1.3, and the Earth's surface gravity is 1.0. So its gravity is a little higher than ours, which means you would weigh a little bit. You would weigh 30% more than what you weigh. So if you weighed 100 pounds on Earth, you would weigh 130 pounds on Titan. So you'd be a little heavier. Let's see. I wanted to check out its greenhouse effect, but I don't actually know if that's. I don't know if that's actually listed on here. Yeah, we do not have Titan mapped out, unfortunately. So you're not getting much out of the surface map here. Semi-major axis. No. Rotation, tidal effects. Roche lobe radius. Still has some pretty cool information here to study, even though I don't quite understand all of it. Clouds. Oh, no, turn the atmosphere off. There we go. So that's what the surface looks like without that thick atmosphere covering it. That's pretty neat. That's pretty neat. And, you know, Titan is half the size of Earth as far as the radius. It's big. You know, its mass is nowhere near that, but the fact that its radius is half of that of the Earth, that's a lot larger than you think. Especially considering that only 30% of the Earth is actual land. There's more land here, assuming there's no water, than the Earth actually has. Which, hopefully, there is water. We know there's, like, methane and all that, but even still. What's this button do? Oh, whoa. Okay, that's cool. Oh God, is it ever gonna go away now? Oh crap, what did I do? Go away. Oh, fudge. Does it just keep looping? Is this forever? Oh, it's gone now, okay. Alright, new simulation. Space. God, this is so cool. Let's see. Let's add a star. And I think the largest star that we have ever discovered, I think, is Betelgeuse. 11.6 suns. 21 suns. Yeah, but its radius is the biggest. Yeah, 4.12. 1.3. I think Betelgeuse is the biggest star that we have ever discovered. I'm pretty sure. If you don't believe me, I can prove it to you. By doing this. If I open our solar system, of course, I think all the planets are going to be in this one. Or all the moons, I should say. But if I open this, and then pause it and delete the sun, and then place Betelgeuse where the sun just was, yeah, that's kind of what I was afraid of. Yeah. There's Betelgeuse. Wow. It completely swallows planet Earth. I mean, look at that. Jupiter is the first planet in our solar system that actually isn't swallowed by Betelgeuse. So as soon as I unpause this, Venus, Mercury, and Earth and Mars are all just going to be completely gone. Just like that. And there we go. So that's insane. And of course, Jupiter is going to turn into a molten Oh, actually, I can't even. Oh, yeah, actually, Jupiter is being pulled in to Betelgeuse. Yeah, its velocity wasn't high enough, so it's just getting swallowed. Bye, Jupiter. Oh, Saturn, too. I wonder if all the planets are going to be swallowed by Betelgeuse. I wonder if their velocities aren't fast enough to keep them going around the planet. So instead, they're just being pulled into the planet. Let's look and see. Well, Saturn is definitely getting pulled in, and it looks like Uranus is also... Yep. Oh, what happened to the sun? What happened to it? Well, I don't know what happened to Betelgeuse, but it wasn't supposed to explode like that. I think that might have been a bug. That was weird. Hang on, let me try that again. That may have been a bug. I don't believe that was supposed to happen. So, again, here's the sun and here's the planets. Let's delete the sun real quick. We're going to pause it so the planets don't just take off in whatever direction they were going. And let's add Betelgeuse again. Nope, suns. Here we go. God, it's so freaking huge. Look, there's the planets. That's insane. Look at that. It literally almost goes out all the way to Jupiter. That's how massive this star is compared to our sun. That's ridiculous. Unpause it. And again, it looks like Jupiter's probably just going to get pulled straight in, if I had to imagine. Yep. Yep, Jupiter's going right into the middle of that planet. Or to the sun, I should say. There goes Jupiter. There goes Saturn. Whack. And I'm willing to bet that... I guess Betelgeuse is moving somewhere, but I don't know where. But it's moving this way for some reason. I have no idea why. But because it's moving, it's going to take Jupiter a second to actually catch up to it to commit to being swallowed. And I think Uranus and Neptune are also following it, but they may get flung out of the orbit. They may be too far away to actually be swallowed. Yeah, Jupiter's gone. I wonder if they'll catch up. Doesn't look like it. So Betelgeuse is going off on its own. And Neptune and Uranus are just going to be dwarf planets now. Huh. We could actually turn on the orbits here and see what's going on here. Yeah, see? Okay. So Uranus and Neptune were the only two planets that were spared, and they're going to kind of go off in their own little world. Yep. I think. I don't believe they're still in an orbit with Betelgeuse, but I could be wrong. You know what's crazy, though, is that even now, I think that Betelgeuse is so huge that the habitable zone around this thing is massive. No, it's okay. They're out of it, but it's still gargantuan. Wow. Interesting. Very interesting. Very, very interesting. Let's see. What else can I screw around with here? Galaxies, objects, minor, moons, planets, black holes. 10 million solar mass black hole. 1 million solar mass black hole. 10,000, 100, 1 solar mass, and Sagittarius A star. Whoa. Yeah, Sagittarius A star is huge. There we go. Doesn't matter how fast time is going, there's nothing for it to interact with. So there's Sagittarius A star, the black hole in the center of our galaxy. I wonder what happens if we put the sun around it, huh? Let's find out. Actually, let's see what happens if we add Betelgeuse to it. If we put Betelgeuse in an orbit around Sagittarius A star. I don't think it's going to actually fall apart or anything, but I could be wrong. Okay, well, something happened. I don't know what. Did Sagittarius A star turn into a brown dwarf? Or not Sagittarius A. Did Betelgeuse turn into a brown dwarf? I don't think it's a star anymore. It doesn't act like it's a star anymore. I wonder if its mass got stripped or something, or if I'm just not paying attention. Huh. Let's try adding another one. There's its mass. Oh yeah, look, its mass is going down like crazy. Ah, so Sagittarius A star is sucking the mass out of it. And once it gets below a certain amount, it doesn't become a star anymore, which I guess is one mass of the sun, right? Once it gets below one mass of the sun, it probably switches over to Jupiter masses because it's smaller than a sun. Let's see what happens when this gets below 1, if it actually turns back into a brown dwarf. Maybe it's like 0.75 masses of the sun. No? Oh, here we go. Yeah. This is the number I was looking for. It's like 79 or 80 masses of Jupiter. Then it turns back into a brown dwarf and is no longer a star anymore. If you watch it, well. Oh, it's stuck at 176 now. Oh, there it goes. Come on. We're gonna wait for it to get to 80. I think once it hits like 80, I think it will actually transform into what the other one transformed into, which is a like a brown dwarf kind of star instead of an actual star. 105. Hey, or maybe it's tapped out. It may stop here. Seems like it might. Or maybe it has to get a little closer. Like I think it's a circular orbit, but okay, maybe this Betelgeuse is actually going to survive. Surprisingly. Okay, good for you. Oh, no, there it went. Oh, okay. Well, eventually it did. And it looks like this orbit is actually catching up to this orbit, so these two might definitely collide with one another at some point. That's pretty cool. There's a lot of things to check out here, but, you know, I'm kind of just fiddling around and exploring things and just seeing what I can find. It's kind of neat. I like it. What are these? Launch. Oh, we can launch things. Really? So, like, if I were to put... Oh my god, this black hole's huge. 10 million solar masses? Oh my god. 10 million? That's so huge. Like, can you even see our sun if I put it in orbit? You can. Damn. 10 million solar masses. I wonder if you can change the... if you change the Schwarzschild radius to something further out than where this sun is, it would technically swallow the sun, right? Like if I make this... Yeah, if it's that big, yeah, the sun gets swallowed. Okay, so like this is an absolutely gargantuan black hole now. Like even if I were to put something like Betelgeuse around this thing, I feel like it would pale in comparison to this black hole. Wonder if it's losing any of its mass, though. Oh yeah. Yep. And then it turned into a red dwarf, or yeah, a red dwarf, I think, or brown dwarf. That's creepy. It's creepy and cool, you know. It's a little of both. I wonder what auto orbit does. I'm assuming two black holes can't orbit one another, correct? Like, I'm just gonna test this last thing right here. Like if I were to put this black hole next to that black hole, well, they seem to orbit. Not sure how that really works, though. Tools. Add. Launch. Sun. I don't know what launch means. Where's the black hole at? God! It's huge! Jesus. Look at how huge this thing is compared to the sun. It's fucking terrifying. Oof. Black holes are creepy and cool, but mostly creepy. I can even turn on orbits. Surprised our sun is still orbiting it without being just torn to shreds. It's not losing any mass, though. So there must be some sort of parameter that I didn't change that would allow it to be, you know, just sucked to death. I don't know. Either way, this has been the first episode of Universe Sandbox, and it's just me piddling around for the moment and trying to figure things out and explore some cool stuff. Hopefully, there will be more in the future, and I might have some more interesting and neat things to show you. Either way, thanks for watching.